Hello, ladies and gentlemen. This is Refraction and Lenses and correlates with Chapter 17.3 in your textbook. Your key concepts for this video are: what influences refraction? How is a mirage formed? What type of images do lenses produce? And what are the differences between concave lenses and convex lenses? So, what influences refraction? As you know, refraction is the bending of a wave as it enters a new medium. So obviously, it's the medium that influences refraction. Now in sound travels fastest in more dense things like solids and slowest in less dense things like gases. Light is the exact opposite. It travels fastest in gases, which are less dense, and slowest in solids. So here we have this light ray, and it's coming along nice and quick. Then it enters water, which is more dense, so it bends and refracts and slows down a bit. It enters glass, which is a solid, where it's going to be traveling the slowest, so it bends and refracts even more. But then it's back into light, so whoop, it's back to its original speed, because that light travels fastest in a gas. And we actually use this refraction in determining jewel types and their quality. Jewelers use a refractometer to look inside the gem and see how does light bend inside this gem. Depending on the amount that it bends and how it bends will tell the jeweler about the type of jewel, its quality, and how maybe it was cut. So all of these things are factors when choosing a gemstone. Now, rainbows are natural refractions. They happen because white light, as you know, is the presence of all color. And each color has its own wavelength. Reds have a longer wavelength, violets have a shorter wavelength. Well, longer wavelengths refract or bend less than shorter wavelengths. So when passing through a prism, red bends less than the purple, so all the colors separate out. Raindrops act like tiny little prisms in the air, so when the sunlight shines through a bunch of raindrops, the light is refracted through them and separates out the color, and that's how we get a rainbow. Speaking of various images with our eye, how does a mirage form? You only see them in the summer, or you hear of them in movies where someone's in the desert and they're dying of thirst. You never see them in the winter. Why is that? It has to do with the temperature. You know that light travels fastest in things that are less dense. And you know from previous sections that hot air is less dense than cold air. So naturally, hot air allows light to speed up. So the air right above the ground is very, very hot, versus the air higher in the air is cooler. So the hot air lets that light that's reflecting right above the ground travel to your eye very quickly, versus the air that's up in the light in the cooler air travels to your eye at the normal speed. So your eye can't perceive this difference in speed, so it thinks all the light's traveling to it at the same rate. This makes it see the distance as kind of puddly and wavy and creates that mirage. It's because of the difference in the light speed. Now, let's review what kind of images that these lenses can make. Just like mirrors, they can create real and virtual images. A real image is an image where the light rays actually meet and come together. You could interact with this image. In the case of a lens, it's going to be beyond where the lens is. And real images are always inverted or upside down. Virtual images, in contrast, never actually meet with those light rays. So you can't interact with this image. It's just a potential image of where the light rays could have met if they went that way. These images are going to always be upright, so in the same direction as the object. So let's talk about the difference between concave and convex lenses. Concave lenses are narrower in the middle and wider on the ends. This means that when light passes through, it spreads out. They can create virtual images that are upright and smaller than the object. So here we've got light coming in, it's refracting through this, so our eye is imagining that the light bounced back and creates this smaller virtual image here. In contrast, convex lenses are thicker in the middle and thinner on the edges, like my magnifying glass. Thicker here, thinner on the edge. Convex lenses can create real or virtual images that are either upright or upside down. And they can be bigger, equal to, or smaller than the actual image. Those of you that have played with this and looked up close at something, it looks big, but when you look at something that's kind of far away, it's upside down and smaller. That's because it's a convex lens. So just to review, here's a handy chart to tell you about the lenses. Remember, convex lenses act like concave mirrors, and concave lenses act like convex mirrors. That's it. Be sure your notes hit all the key concepts and vocabulary, and feel free to try this challenge question.